Good morning, QED coders. This is Michael. All right, checking audio levels. Looks a little bit low. Bump that up a little bit. Hey. Good morning, Dumpling. All right. Yeah, I'm probably going to have to do... Yeah, that is full volume now. Okay, cool. All right, as we're waiting for Jan to join, there are a few things that I wanted to go over today. Yeah, I just worked on some variadic parameters using TypeScript, so that is a really cool feature of TypeScript. Yeah, it fully documents what's happening in JavaScript. That's what's amazing about it. That's pretty awesome. But yeah, using variadic parameters and type functions, I'm able to make something that declares what's really happening and makes it make a lot of sense. And then going over the I made the query function j.query work with specifications. So that's the new specification format, and I made that an overload, so you can still use it the way that you have with the template functions, or the specification functions as I called them, or you can switch over to the new specification syntax. And so doing overloads in TypeScript, again, documents what's really happening in the JavaScript. It's pretty cool. All right. And it looks like, hey, good
Michael,
afternoon, Jan. How do you
good
do?
morning.
Good to
Doing
see you,
fine.
sir.
What about you?
Doing very well. Very well indeed. Yeah.
Okay.
Yeah, last night I had a really good time. We hosted Code Launch here in Dallas. That's an event that highlights founders in our area, and gives them a chance to make their pitch. They get feedback on the pitch, and a really cool part about that is that several different companies, Improving included, volunteer teams to spend 24 hours hacking on their solution. So
Yeah.
yeah, it's a pretty cool event. Yeah, people who've described it to me before I went said that it's like Shark Tank, and
Yeah.
so I didn't want to go. It's like, why would I want to be part of Shark Tank? This is a terrible show. But then I went, and it's just completely the opposite. It's just positive and uplifting and supportive. Yeah, nothing like the show.
But so it's developers proposing solutions and then other developers helping them,
Uh,
or
yeah, it's founders proposing solutions. So like uh, one of the startups there was a lady and her father. She came up with this idea for asking her wedding guests to instead of giving gifts from a registry, donate money to pay for the wedding, and which is actually not an unusual thing in a lot of cultures, but for some reason in the United States, it's just like, that's just weird. Um,
yeah.
but yeah, she's like, okay, that worked out so well. I really want to support other brides doing the same thing, and so she built a platform that you get a QR code, or a link directly to your wedding page, and it just describes the event, and then the different ways that you can donate. And then they collect the money, and then you get to use that leading up to the wedding. So it's not like
Okay.
they collect the money and then after the event it's like, okay, here you go. It's like, no, we need the money now. Let's yeah, let's just
Yeah.
bring it through, get the wedding going, and yeah,
If you don't pay, there is nothing to eat on the event.
yeah,
Yeah.
exactly. Yeah, so she
And
and her father had this idea, and then they found developers to kind of help them build the idea. But then, in addition to that, by becoming a finalist at Code Launch, um, one of our local consulting companies donated 24 hours of a team of 5 people to
okay.
to
Mhm.
take what she had already built, and like, okay, let's really make this thing make the thing awesome.
Okay, and they always make it that way that within the 24 hours they have something concrete, something working.
That's what they strive for. In some cases, the founders just need um, a website to promote the idea. Yeah,
Mm,
so it's really what the founder needs. But yeah,
yeah,
that's what they really strive for. Just something workable.
yeah.
Yeah,
Or it might just be some consultancy on where to go, which direction, which which technology to use.
I hadn't seen anybody doing that. I saw hands-on keyboards,
Mm,
from each of the different teams. It's just what they built was dependent upon um, what the founder needed. Like the improving team, um, built a mobile application for this founder. So this one was changing the way that hiring works. Um, so um, so gathering information from the market on from the labor market on salaries and then
mm,
um, as a hirer um, you can put together a team and then execute on the hiring all at once. You have the team
mm.
work together for whatever period of time you need them. Um, so it's um, so it's different from your dice.com kind of job site thing, but then from uh, from the labor side, it's a little bit like the Upwork model in that you're participating in this marketplace, but but also different from Upwork because this is what they envision people using this in order to find the right time to switch jobs. So it's like,
Okay,
okay, this is the salary that I want. Salaries aren't there yet. I'll just wait until I see some alerts, and then I'll start to participate and compete. So, but yeah, they didn't have a mobile app, so in 24 hours, our team put together a mobile app.
you were part of the team.
I was not part of the team, no, no, no. But yeah, maybe next year
Mm,
I will be.
okay,
It was
so
an eye-opening
that
event.
that would be nice to do the analysis with historical modeling.
I think so. Yeah.
Yeah,
Yeah. So I think
24
next
hours.
year.
Let's see what you can build.
Yeah. Yeah. Next year, Jinaga.net and Jinaga.JS will both be to a point where I
Mm,
mean, if you want to do it on Xamarin or on Maui, let's
mm,
do that. If you want to do React Native, let's do that. Um, and and yeah, I strongly believe that yeah in 24 hours with this technology, you could build just incredible things.
that would
I
be
think it's going to be
amazing.
like that. Yeah.
Yeah.
Yeah. Maybe we can do a 24-hour hackathon on DSW or DWS.
I will I will send in a proposal. That would be nice.
Yeah. Yeah. I keep
Yeah,
on mixing up, by the way, that acronym because DSW is Dallas Shoe Warehouse. So that's a local
yeah,
shoe
yeah.
retailer. So
No, DWS, digital
yeah.
worksheets.
Digital worksheets. Okay. Yeah.
Yeah, that's where it
I
comes
don't.
from.
Yeah.
But
I don't know that I actually knew that.
okay, I saw this diagram
Yes. Yes.
and I said that's a good idea.
Mm-hmm.
But because I actually the one of the main difficulties is all the types and the interfaces that you defined in JavaScript.
Mm-hmm.
Um, the more you start going through the code, the more you see the relations. But I think to get into it faster, it would be very nice to have a nice overview. So what was it? Um, yeah, like for example, let me share that. Sometimes I find back things which I slide before and I forgot. And then this one, I think. Yeah, so yeah, that should be visible. Just a PowerPoint. Is it visible?
So far, just a white screen.
We're still calculating then. We pause this preview to save your resources. I know that I'm not seeing it, but you should be.
Yeah, I'm just seeing a white screen as well.
Well, there are options here, and then it starts. Tells me live. 30 frames per second. I have the option to report problem.
Yeah.
Still nothing? Still nothing?
No, nothing. So I wonder if instead, if you shared, instead of playing the PowerPoint presentation, just share the
No,
editor window.
I was not playing it.
Oh,
it's just a slide. Let's try it again. You never know. This one. It says smoother video. Let's say better text readability. Let's try that one.
Okay, and white screen again.
And now it's 5 frames per second. Still nothing?
Oh, wait, there it comes. Yeah, now I see it. Yeah.
Okay. So, I found this back. I don't know when I did this one, but this was the structure of a specification in JavaScript.
Okay, yeah. Yeah, this seems
and
recent.
And then I realized, yeah, but sometimes I make things and then I forget about it. And then I realized that actually a result description, or what was it, a query? A query description. What was the correct name for that? You had something with a query description, a result projection, and a child.
Yeah, and I ended up with 2 versions of query description. So one of them is called a result query description, I think.
Wait, I should be able to see it here. That's the read. That's the other one. Build description, result description. Yeah, there is an interface which is called a result description.
Okay, yeah.
Which contains a query description, a result projection, and a child result description, which is actually just an iterative thing. But so that result projection, the second item of that, I thought I have to define all these components. But then I saw that actually in that screen here, you have the hash projection, field, element projection, specification. All these elements exist already in .NET.
Yes.
Because you needed them to define a specification.
Yeah. In fact, I created them first in .NET, and then what you're seeing there is porting the new specification structure from .NET into TypeScript.
Okay.
And projections made it almost exactly in the same form. The specification and match and condition that ended up a little bit different because JavaScript is different from C#. But yeah, our projections were pretty close.
But so actually I didn't knew that until I saw back this diagram which I made at one point, and I think it would be very useful to have, here I just had 2 arrows, but so specification, the child projections here, they point to here,
Mm-hmm.
this projection point to here. It's the whole structure.
Yeah. Yeah.
And it would be very nice to have a kind of type structure diagram. I was looking for an extension for VS Code to have something automatically in JavaScript. I didn't really find things which generate useful structures.
Mm-hmm. Yeah.
I found a few things which which worked half, but nothing which was up to the current TypeScript version to be able to interpret all the structures.
Yeah. Yeah. My experience with those tools has been they're less useful than just reading the code.
Okay.
Because they don't have any more information than the code has. And a diagram is supposed to infer intent, and intent originally comes from the designer. So it's really hard for a machine to infer intent from code if a human's going to have the same trouble inferring intent.
Yeah, but in the code you have so many definitions, so many interfaces,
Mm-hmm.
and you don't see the structure, and why do we have this, that, there, the naming.
Yeah.
I still find this useful. Yeah, perhaps if you developed it yourself, you've been thinking so much about it
Mm-hmm.
that the name is part of your knowledge.
Well, yeah, I must admit that even I returning to code that I wrote 6 months ago, the names don't help me either. So yeah, it's just the name comes up in the moment, and it's like, okay, let's try that. But yeah, having um, a consistent way of choosing names in the first place would be useful. I don't know how to do that though. Naming things is one of the hard problems in software.
Yeah. Sometimes if you compare the 2 versions, you say, hey, why is that named
Mm-hmm.
this way and the other one is completely different?
Yeah. Yeah, and what I'm running into now is that I'm coming up with names that I've actually already used in the previous template mechanism, and it means something slightly different over there, and so it's like, okay, I need to figure out, can I reuse this name because I'll never import those 2 things at the same time? Do I actually have to give them different names? So that's interfering with any attempt that I'm trying to do to make the naming within this one context consistent. But yeah, it is difficult to understand how all of the pieces fit together. So yeah, I agree. Yeah, the diagram that you just held up, I went from specification down to match and stopped there at that first level, because
Yeah.
that diagram would get really big if it went all the way down that way. But then also said projections, but I just picked one interesting kind of projection. I just did the which one was it? The specification projection. Yeah.
This one you mean? This diagram?
Yes.
Yeah.
Yes.
It's that where you have here at the bottom the specification projection, which
Right.
yeah. Yeah. No, I don't know. Apparently you don't agree on the diagrams.
Yeah. Yeah.
But I
Well,
still,
I think I'm with you. There needs
yeah.
to be a second diagram, one that's more detailed.
Mm-hmm.
This diagram, and actually I'll bring it up on the screen here so people can see it a little bit better. Okay, close that. Share that. Okay, so we got that. And okay, there we are. So, so yeah, the diagram that we're talking about is in Jinaga server. Now it's been moved under docs SQL. Yeah, this, as you were pointing out before, this documentation was buried inside of the source code before. So SQL from specification. So now we've got a diagram that that shows the various layers of this this transformation from a specification into results. And so yeah, I think having this this full diagram exploded out would be useful. That would not be in Jinaga server because this specification actually is defined inside of Jinaga. It's more generally useful. But yeah, we've got labels. We've got matches. Oh, I did do field projection and specification projection, but there are other kinds of projections that were not terribly useful for this particular transformation, so I left those out. So yeah, and then under match, we've got conditions, and you know, those are either path conditions or existential conditions. Path conditions are made up of roles with you know, with a label on the other side. So yeah, there's a lot going on underneath match. But here I just said, well, a match has an unknown and then other stuff. Yeah, so
Yeah.
but yeah, so the important intent that this diagram is showing is that there's a process by which this specification tree is transformed into a result composer. And the motivation for having a result composer is that it captures what the system needs to do once it has results in order to turn them back into some JSON. So results being SQL result sets. So yeah, the result composer, it says, okay, here's some SQL that you could execute. There's the actual text that gets generated. So the result composer knows that you're talking about Postgres in this case. Here are the parameters to put in there, the labels that those parameters represent, so that you could eventually tie them back to different parts of, to identifying different parts of the structure. And then the bookmark is still in here, but for results, bookmark doesn't actually make sense. So I have to figure out, can I remove bookmark from here, or I mean, it's vestigial. But at the very least, a SQL specification query is something that you can give to the database in order to get a table of results. And then every field projection turns into a projection, where you've got what do you want to name that that projection inside of the result? What's the field name that you come up with, or really the JSON property name is what that means, and then the label of which object, which fact. And so you've got the labels up here that tell you when you select those results out, what are the various columns, what do those represent. So this label eventually tells you which column to use in the result set. And then one of those columns is an actual BSON object of the fields, not the whole fact, just the fields of the fact. And so this says, okay, which of those fields do I want to use? So every field projection becomes one of those, and then every specification projection becomes a named result composer. So that's a result composer with a name. And so that you create a tree out of those things. So, so now that you've built these result composers, you have the instructions for, okay, if I were to run some SQL, then I would know how to turn this back into a JSON object. And I go into one additional interim step before really executing the SQL. The SQL specification SQL query just comes straight over. This is the same object as that one. But in order to know how I'm going to be executing these queries and how the results are going to be packaged, I basically collapse the tree. So I've got my named SQL tree that's just related to the named result composer. And the way that I can walk this structure is that I know that I'm just going to send all of this SQL. I think I send it all at once and then do multiple result sets. And then I know which of those result sets maps back to which of these. So it's just one trip to the database and then I get all the results back. I think that's right. Rather than n trips. In hindsight, I probably could have run that operation directly off of this because this is already a very similar data structure. But that's where I ended up. And then we asynchronously actually run all of these SQL queries. We get back those result sets. And we have those. We put those back into a tree structure after they come back linear from the database. So now I've got this tree of named result sets. And then the result composer can take that result set tree and hierarchically, iteratively, recursively run through and build that tree back into a JSON object.
Yeah.
So that's kind of the story that I wanted to share with this diagram. And actually, that last part of the story is what I intended to write under that section, but still haven't gotten to that. But yeah, all that in between of how it actually produces the SQL and gets it ready to send to the database. That's what's in that text there.
But that last paragraph, I'm not yet there yet, so
Mm-hmm.
I didn't miss it yet. No, made some progress going through it. Actually, I'm not yet into the testing first. I looked a little bit into that first test, but the first code, when I get back into the Git history, it appeared at once. So apparently you did a great job and you committed it all at once. But
Okay, yeah.
Okay, by going through the code more and more, I start seeing it more and more in the steps. So we are getting there, but too slowly.
Yeah. Yeah, so there was yeah, actually it's going back quite a ways to actually see the okay, was it one of these merge commits that you were seeing?
Actually, I went through. How did I do it? I tried with the blame instruction that we tried together last time, and in the end, no, that was.
Oh, that's the wrong one.
Yeah. Where's mine? In .NET, it had to do with the memory. Where was it here? That memory store. Each time I need it. Yeah, it was on the storage. Okay. And then if we go to the testing for the memory store, where model pipeline, the query test, that was it. And if we go then to that first one, here we had the changes, and then yeah, that was what I did. So I went to Jinaga.net to the query test that you wrote for the memory store. There you have query test somewhere. No, it's the test test themselves.
Yeah, so the store test, is that right?
The query test.
Query test. Okay.
Yeah. It's on the Jinaga.test. More down.
Okay, there it is.
Yeah,
okay.
There. And there, wait, you had that very first one. I lost it meanwhile here. Query test. Can query for predecessor.
Yeah.
Yeah, and there you have one author, 5 changes. In my case, it gives me 5 changes. In your case, 2 changes. Oh yeah, but I changed the changes in months to 100. That was the difference.
Okay, yeah.
Okay, and then you have there show all the file changes. And then you got a very big list. And then I walked through them, but you have a lot from 2021.
Okay.
Which were, and then somewhere in one of them, don't ask me which one it was. If you, no, it's not. If you double click, you see straight away the old code. But if you just right click, and you see view commit details.
Okay, nice.
Yeah, and then you say query test. You can see it appear.
Okay. Yeah, that is helpful. Okay.
But so you have to go through the history, through all that, the commits to see it appear. And what I found was that what I needed appeared at once. So I say, okay.
Okay, so yeah, if I were looking at query test and I saw this, it started there. Started test for in-memory implementation. That's on 629.
I'm still wondering. I didn't search further. This show all file changes. What is in fact the real meaning of that?
Yeah. Interesting. So, okay.
Because
so we started here with the helper for this one test. So
this single routine in that single file.
Yeah. So these 5 commits touched this one function. But if I show all of the changes in this file, now all of these commits touch this file.
That was yeah, all the other tests that have been changed.
Yeah.
Because then if you go to the commit details, then you also see the other files that were involved.
Yes. Yes.
Yeah, it must be that.
Yeah. Okay. Yeah. This is pretty nice. View commit details. Okay. So yeah, for this commit, I added a test, k-inquiry for successors. And then to make that pass, execute step looked for a successor step now instead of just throwing not implemented exception. And then, yeah, that I think actually this was the thing that that confused me before, is that I see the call to execute successor step show up, but execute successor step is already in the file, and that's not my usual style. Yeah, I don't usually write a function with nothing calling it. So
okay, so
yeah.
so you made the code before you wrote the test in that case.
Yeah.
Yeah. Well, usually you make the test first and then you start implementing the code.
Yeah, and not only was it code before test in this case, it was write this code before anybody even called it. This one here, execute successor step, is the only call to that is this one that I added right there. So yeah, that's just weird. I'm not sure why I did that. But I mean, maybe it was that I just hit enter and then Copilot just said, hey, you know what? You're going to need this one. It's just exactly the opposite of that one. I said, yeah, you're right. Boom.
That could be. But that was a commit from July 2021.
Yes.
That's strange. 7.8. And on my system it shows 9.7. Yeah, 9.7. Wait.
Okay.
In your
so
case, it's month.
Yeah.
It's month day. But.
Yep. And then yours is also changed to the
Yeah.
right time zone. So yeah, I did this at 10 o'clock at night here.
Okay.
And then that was the next morning for you.
Okay. So 7.8 becomes 8.7, and then in the right time zone becomes 9.7. So okay.
Yep.
That explains why there is a difference. But then this executor step, where was it in tests? But that was that already the implementation of the new specification? No.
Yes, this is. So in Jinaga.net, it's only the new specification. Jinaga.net doesn't have the old style.
Okay.
So yeah, right now I'm going through the process of migrating all of this Jinaga.net code back to Jinaga.js.
I'm surprised that that's already more than a year ago that was implemented.
Yeah, I know. It's crazy.
Okay.
All right. Yeah, that is a good tool.
Yeah, but so I started going through that a little bit, but didn't really found it useful at this point in time. So then I went back to the JavaScript code.
Yeah.
And looked some further, and yeah, it starts lighting up. Together with that old diagram that I found back, and then starting implementing slowly. translating structures, and so on.
Yeah.
Um,
Yeah. So, yeah, I've got it on my list now to uh to yeah, got it on my list now to um to explode this diagram out, make it more explicit, and that actually will help with the documenting the math behind it. So document the CRDT, because you have to understand this specification structure in order to understand the operations that the algorithms perform in order to invert the specification, compute the feeds, and those two things help you prove additional properties of the history CRDT that are not general CRDT properties.
okay.
So,
Yeah.
yep, that's going to be very helpful. So doing that with intent is going to be necessary, and yeah, if I can make the names make sense. Actually, these names I think make pretty good sense, because these are the names that started in .NET. As I did the transformation, I had a chance to kind of think through them, and do these names make sense? Yeah, I think they do. So there wasn't a lot of baggage that went into it, into the names. So I think they're right.
Yeah. But so that was for the specification. But so the same structure would be very useful for the query description then. Yeah, actually, okay, that's inside here. But so my diagram was just on the specification, and it was missing
right.
that portion of the query description.
Yeah, that's right. Yeah, this diagram does not include the query description. It talks about it. Yeah, query description. It says that this is an immutable data type somewhere up here. Actually, I think it's... Oh, yeah, this is actually the first mention of query description. That's an immutable data structure. And so, yeah, it's like, the query description is the the record keeper that moves along as it turns this into that.
Then another thing that where we might add some documentation is the data structure used. For example, you're often using maps in Java. But actually, why are we using a map? Because we have to find something based on a key, or what is exact the purpose of that. Because the moment that we are going to translate it with .NET, are we going to use a dictionary? Are we just going to use a list?
Yeah.
Now, I start with the list, and when I see that you need to search for something, I can always make it when it's a key-based search. I make it a dictionary or whatever. But to make the translation to other languages easier, would it be useful to document that at each structure level, or would that go too far?
Yeah, I don't know. So yeah, let me see if I can put like this one right here. Fact by identifier is one of those maps that that we use. So you've got the identifier, and then fact description. This identifier might actually mean label. That might so that might be one of those places where I hadn't settled on the right word yet, so that might be label, or maybe I was thinking label means a name and a type, and this is just the name. So yeah, not really sure, but yeah, where fact by identifier is used, we've got that's a parameter that goes into each one of these recursive descent functions. So it's like, yeah, here's like the symbol table. These are all of the names that I know about so far, and so that just keeps on getting passed down into each one of these functions, and sometimes the function, like this one right here, it's taking known facts and returning known facts, because this function add edges is going to add more yeah, actually add path condition is the one that's going to add more stuff to known facts, and so it's yeah, right here. So I said, okay, I've just found a condition, and so now it's time to put that fact description into the symbol table. So it yeah, that might be useful to document in relation to query description. So it's kind of in the same vein as query description, where it's a a worksheet that you follow as you go down these recursive functions. So yeah, each one is going to take in, hey, here's the current state. It's basically like a stack of everything that you've seen before, and then, okay, let's do our little piece of it, build it up, and return that.
Every iteration you add information to it.
Yeah.
But
yeah, like
I'm not sure how to document that structure in such a way that you can immediately select the right structure when you do translation to another language.
Yeah.
Because to know that, you have to walk through the code and see how are we using that structure. Perhaps there is not a not a good way to document this. I don't know.
Yeah, I'll give it a shot. I'll see what we can do there. So include facts by identifier.
Oh,
Yeah,
even for example, the very simple ones that was in the beginning, where was that?
Yeah, we kind of kick things off. So,
yeah, if you go to the read routine in Java, it's in the Postgres store. No, it's in Postgres store. Yeah. Line 2, 3, 4. Yeah. For example, these fact types and the role map. You can just make it a list.
Yeah.
Yeah. If you look at these structures, then you say, yeah, what do I need there as a structure? How we pass it into that builder later on. But how is it going to be used?
Yeah. Yeah, so I do these, the fact type map and the role map as maps, so that I can quickly look up the number associated with the fact type, and then for a role map, I start with the fact. Yeah, that's the fact type ID that's actually in the database. And so for the role map, then now that I've got that fact type ID, I can then look up each of its roles. I can look up a role for that fact type and get the role ID. So yeah, they're numbers so that you get you get constant time lookup of those numbers, of those IDs. Well, login anyway. Close enough. These are going to be very small, but yeah, if you did it as a list, they'd be very small lists. So iterating the list would be pretty fast too. Yeah. So the way that they are used is you first of all populate these.
From
So
the
that's why you
database
call
in the
these.
cache.
Yep.
Yeah.
And then now you've got confidence that every fact type and role that is in your specification that is also in your database are in here.
Yeah.
And so then as you are building the results, so that's where you're now building the result composer. You're putting together these parameters, and the IDs actually go into the parameters. So it's already done that selection from the database for the so you don't have to have the parameter be the fact type string and the role name string. So saves you a join on each of those different parts of the query. So that actually will save quite a lot of joins, and then those are pre-cached. So yes, I am. So the data is stored in memory. So when you go back and you load them again, it's like, no, I already know those. They haven't changed. But then furthermore, when you walk through these results, build these this result composer, if you don't know about a particular fact type yet, then it just prunes that entire part of the tree and says, there is no data that I could find that would cause this to have any results. So this is unsatisfiable. And so an unsatisfiable results will just immediately turn into an empty result set. But then if it's inside of an existential condition, it will just automatically evaluate to true for not exists or false to exists. So it's like, nope. And then it'll pare down that where clause where that existential condition appears. And so this SQL actually gets shorter based on which IDs it knows about. So yeah, that's those little maps are doing a lot of work.
Yeah. And then, for example, in that role map, there we call it role, but in .NET, in the projections directory, we already have a role object, but that role object is completely different.
Yeah. So the role, this string right here is the role name. So
yeah, so that's what we have in both.
Yeah, and this number, yeah, you're right. These numbers relate to IDs that are in the database, so they are not part of the structure. They are now part of the storage. Whereas this is still just all structural. This is all completely abstract. No database IDs in here. So this
For example, there we call it in role we call it the target type.
Yeah.
And then in the database we called it the defining fact type ID.
Those are actually opposites. So when you've got a fact that declares some predecessors, it names those predecessors. Those names are the roles, and the target type is the type of the predecessor. But it was the successor that defined that role, because that role is a property of the successor. So the defining fact ID is the successor's fact ID. The target type is the predecessor's type.
Okay, yeah. I was thinking about that, and finally I said, yeah, it's the same, but no, it's not the same.
Nope. Yeah, those serve different purposes. Yeah.
Okay. So it's even completely different.
Yep.
Hmm. That might be something interesting to, instead of target type, why not we call it predecessor type. And the defining type ID, we call it successor type ID.
That makes a lot of sense, actually. Yeah, because then when you get to code that that will, let's see if we can find some code that that does that real quick. So result SQL for specification. So we build the description.
These are all details, but
yeah,
when you translate it, it's there where it gets confusing.
Yeah, so when we come down here and we add edges, we've got a path condition. So let's go ahead and add that path condition. And so the path is going to have it's going to have an unknown. So that's what the match declares the unknown. And now the path condition joins that unknown to some other identifier. That's why I use the word identifier. An identifier can refer to a given or another unknown. So, but yeah, that's also what label means. So, yeah, okay. So yeah, it joins it to some other label. Yeah, okay. So that's why I called it label right. So label right is the label that's defined previously that that we're joining to, and then there is no label left because that's the unknown. It has to be joined to this unknown, and that has to appear on the left. And then we've got the roles on the right and the roles on the left. So yeah, when you come down here and you are walking through, first of all, the right hand roles, because you start with this previous, you go roles right, and then each one of those is a predecessor join. And then you end up with with an edge that joins this known facts fact index to the new fact index that we are that we're keeping track of as we walk through it. So I think in here is where we kind of turn the corner between declaring and target into predecessor, successor. I explicitly give them the names, the predecessor fact index and the successor fact index here.
There it's done that way.
Yeah, so that's where it kind of shifts from one, and it's hard to see that those mean the same thing when it's like these are just the names of the parameters and those are the names of the arguments. Yeah. Here I gave it I renamed fact index to predecessor fact index. But yeah.
We need some refactoring, some cleanup there.
Yep. That is true.
Just all small details where I run into, but sometimes it complicates things.
Yep. Okay, so yeah, I've captured that. So target and declaring facts versus predicate successor facts. Yeah, or types.
Yeah, there were a few others, but each time I run into things like that, I will write them down.
Okay, yeah, that'll be helpful.
Might be interesting. So then with some suggestions how to name them.
Mm-hmm.
Hoping that my suggestions will be better than than the original, because it's not always easy to find good names.
Yeah, that is true. Okay. Yeah, so I've captured some of those notes over there. Yeah, we didn't get a chance to talk about the uh, you know the Jinaga.JS. I'm now able to pass a new specification into query, and so I'm currently working on the memory store and making it execute a query from specification. So there, I'm porting code from .NET into JavaScript, and
Okay.
going through the same process that we already talked about, where just just enough to get one test passing, even though I've already got the other code over there, and I can see the code side by side to say, okay, I know that I'm going to have to write that eventually, but just test drive my way and move test by test. So yeah, we can go over that next time, and then yeah, you added the debug script and submitted a PR. So that
Just a
PR
small
is in
thing.
there. Yeah.
Yeah, I saw it was added.
Yeah. Oh, and I wrote these on the wrong day. Let me move those to the right day. Yeah, I'm keeping notes off screen here, but you'll see it in the... There we go. Okay. Yeah, so you'll see that in the feed. Okay, excellent.
Right. Oh, it's 16 hours already.
Yes, it is.
Your working day is starting.
Yep. Yeah, very true. So, yep,
Mm.
need to get to my team. But yeah, um, we'll make that easier for everybody to follow. I want this to be a reference implementation, which means people should be able to refer to it. So yeah,
If we have everything well defined, then it should be reasonably easy.
mm-hmm.
That's a difficult word to follow it.
Yeah,
Okay.
yeah.
Next week you will be there.
No, next week is Thanksgiving, so nothing
Okay.
next week. But then
All
yeah.
right. Let me see, because I might be away from the 3rd to the 10th of December. Okay, but that's yeah, so no problem. So the next will be the 1st of December.
I believe so. Yes, correct.
Yeah. And then the week after 8, I'm not sure whether I will be able to
Okay.
follow. Might be, might be not. I will not be in my office, but
Mm-hmm.
depend on whether I have a good internet connection.
Okay. So yeah, if you're not, I'll go over the progress that I've made up to that point. Who knows? I'll probably have Jinaga.JS, the new specification, query inversion working, and watch. That's the next couple of things on the stack there. I'm trying to drive that toward a place where I can start the Jinaga experiment in JavaScript and have them use the the new syntax for everything. So write some unit tests, write some components, do this in React, do this in React Native, and hit the hit the replicator, all that fun stuff.
Okay. Great. But in 2 weeks' time, I'm certainly there, the 1st of December.
Okay. Very good.
Okay.
Well, then
Michael,
we'll see you then.
enjoy Thanksgiving,
Certainly will.
and see you in 2 weeks.
Right. See you.
Okay. Bye.
Bye.